Alrighty. Okay, so your lab number 1 is due tomorrow, so please make sure make as much progress as you can, and then I'm going to release the solution walkthrough video to you. You can take that as a study reference, and your programming test number 1 will be next Wednesday, which will be October 8th. Okay, so the guide is already there, and also I release a practice test over there, and then there will be a review session this Friday, 2 p.m. and Curtis Lecture Hall C. So I will be there, but it's going to be one of the TAs who's actually going to lead the review session. But you know, they took the same course before; they're very good, so you don't have to worry about the quality. So I'll be there, so you can definitely ask questions as well. But it will be, so just please make sure you come 2 p.m. All right, and then your programming test 0, we started the grading process, and I'll definitely try my best. Of course, the TA will try their best as well. They are really the people doing the grading. We'll try to release at least a result back to you by next Monday class. We'll try our best, because there will be different parts we have to coordinate. So I already started the process, and we'll make it as smooth as possible. So guys, any questions? So we basically got next Wednesday programming test 1, and then we have a 1-week break for the reading week. After that, we'll hopefully, after a few more lectures, 1 or 2, and then we should really start talking about inheritance, which is really the meat for this course. Okay, we'll talk about it. All right, let's now recap very quickly. So just in case you haven't really caught up with the very last 20 minutes from section G, right? Remember, we kind of finished the class earlier last Wednesday. So please do so, 20 minutes. It shouldn't be too big a deal. I'll try to also recap what you're supposed to know from that 20 minutes. But to really see the detail, you better see the lecture. Okay. So let's take a look. And then we'll continue with the discussion on exception. So we introduced the ideas about caller and callee. Basically, every line of method call, you're going to see caller and callee. Every line of method call. And then we talk about call stack. We're going to see even more today. So today I plan to talk about the 3 different versions about handling, namely either to specify or to catch an exception in different classes. I'm going to show you the different possibility. Hopefully that can make you feel a bit more intuitive about how the exception work. But of course, to really trace the exception, you really have to boil down into method call, like a chain of method call. So this page over here is very important. And then either before or after the break, I'm also going to generalize about the ideas about catch with specified requirement. That's also going to hopefully help. Okay, but things will come. And then this page here is also our first exposure to the catch with specified requirements, right? So you got a call stack over here. You got the entry point of execution, and you got 1, 2, and 3 method calls. As soon as some exception occur, the call stack will stop growing. So this will be the point where things must happen to really deal with the exception. And rule number 1. The method where the exception is originated will typically choose the specify option, which I'll show to you in version 1 about the example. And then starting from this point over here, the caller of the method that actually where the exception is originated. This method here has 2 choices. Either they can try to specify or they can try to catch, right? Either way. In this case, the method will try to specify. That's why you see the arrow here will go from M2 into its caller. Simply means the exception object was not called. It simply propagated or thrown to the caller. Okay? On the other hand, this caller here, again, he has 2 choices, either to catch or to specify. In this case, chooses to catch. So that's why the arrow only go back to itself. And there's something I also want to show to you on the Eclipse as well. As soon as a method in the call stack catches the exception, that means all the subsequent caller from this point, in this case only the main method, it is no longer subject to the catch or specify requirements. So what do I really mean by that? I'll show to you. Because a catch or specify requirement is enforced as a compilation level thing, meaning that if you don't really follow that, you're going to get into compilation error. That's something you definitely want to avoid in the programming test. Not programming test 1, but programming test 2. But to really, the best chance to practice will be to try out the example I'm going to go over with you today. You can feel free to extend it, and also lab number 2, right, which I'm going to release pretty soon. Lab number 2 will also give you lots of chances to practice exceptions. All right, this page here, just make sure you study. I'll make this page generalized today as well. And we talk about catch with specify requirement. In the case of specify, you would just have to make sure you say as part of the header, throws some exception. If you got more than one exception that can be thrown from the particular method, you can say throws exception 1, comma, exception 2, comma, exception 3. That's also valid syntax. That could be useful for your lab number 2 later. And the catch option here means you want to have a try and catch block over here. There's going to be a single try block where you call some method that may or may not throw some exception, right? And then in the catch block, you can have as many catch block as you like. So each catch block is supposed to catch certain exception. You simply put their name right here. It's more like a declaring some parameter. So you can name the name of the parameter any name you like, as long as it doesn't clash with the attribute value, for example. Right? And then you can do something inside. That's something I also showed to you as well. So in the exceptions lecture, we don't really say much about what you should really do in the catch side. But I think later, once we get to the next lecture, when we try to play a little bit more with the execution flow for exception, you will see a little bit more manipulation there. But of course, you're only bounded by your imagination. When you're in your lab number 2, you can feel free to put some code inside the catch block and see how they execute. That's something you want to experiment as well. Okay. All right, and then we kind of started, this is actually part of the 20 minutes, right, that you're supposed to catch up. But this one here, it basically shows you the setup. So we got 3 classes. We got class A, B, and tester, right? So tester, the main over here, is going to be the entry point of execution. And then that one there is going to call a method called MB. MB is a method here, so that's why I put it on the stack. And then MB itself is going to call MA. MA comes from class A right here, so that's why it's the top. And MA is the place where we might throw some exception, which I'll review the code together with you, right? And then we want to kind of see, as soon as the exception, which is called negative value exception, as soon as the exception is somehow originated from here, this method here has no choice. We just specify it. That's always the rule. That's rule number 0. And then starting from MB and also main, we got different options over here. So I want to show you just some of them, just to see how they work. All right? So when you review this particular example here, just kind of see what are the variants you can have, about handling the exception. Let's get back to, let's go to Eclipse, and then I also got some tracing ready. So we got to do some tracing as well. Okay? Tracing is very important. Okay? So let's talk about version 1. Okay? So let me just show you the code very quickly about version 1, and then we can use the breakpoint and debugger to strengthen our understanding as well. Of course, there will be something I wish you can also reproduce, when you go home and follow with me in the video. All right, so we got class A over here. Let's take a quick look. So for class A, we have the method MA. You can see we have the specify option. That's why it says throws negative value exception. That means any caller of MA, they will be subject to the catch with specify requirements, which we'll see. Okay, any caller of MA, in this case, b.mb. Okay, and then inside the MA, the logic goes like this. If the input parameter is less than 0, we consider that as an error. In which case, you can throw some exception, right? So you say throw new negative value exception, and that's something you can check to see how to create a new exception class. It's something that can be automatically generated in Eclipse. For that one, I'll leave you to practice. I also put one line right here, right before the exception was thrown, right here, line number 8. So this one just say, if you somehow reach this particular error condition where I is less than 0, I call that abnormal execution, right? Just not normal. On the other hand, if I go to the else part over here where I is larger than or equal to 0, I just print out normal execution of a.ma. I'm just using some system out of print line to see where we are going for the execution flow. Okay? Right? Any question about class A? Anything that's not clear to you? There are 2 things over here. Okay? Number 1, to really throw the exception, you got to say throw new right here in line number 9. Right? So that's the throw keyword and also the anonymous object, which we review in the OOP slides. Okay? Number 1. Number 2, in this method where the exception is originated, we try the specify option. So that's why we say throws. Okay? And the throws should really go between the closing parentheses and the opening curly brackets. Right? So these are the 2 things you want to watch out for. All right, so let's see the caller of A. Okay? If I go to method B, sorry, class B, right here. Okay, so here you can already see we got the try and catch option. The try the try option here. Let me just go back a little bit just to remind you very quickly. Let's say I don't have this try block. Let's say this. Let's say I just comment this whole thing out. Okay, let's say it's not there. And I just want to make a method call right here. Just like that, right? So only 2 lines are effective now, especially for line number A, I'm trying to call MA from MB, right? But I have a compilation error. If I move my mouse over the red underline, it says that unhandled exception, negative value exception. So this is a compilation error I was talking about. Every time you're calling a method which specifies certain exception. In this case, MA specifies negative value exception, if you recall, right? MA, right here, the callee, specifies the negative value exception. So that's why here the caller, MB, will have to somehow subject to the catch with specified requirements. 2 options, either to specify or to catch. Let me show you, just in this case, the catch option. All right? So that's why this line alone is not going to work, right? So let me just delete that. And let me go back to the working version where we commit to the catch option, right? So this is okay. So we put the method inside the try and catch block, and then we say catch, right? And the catch will catch the negative value exception, which might be thrown from MA, right? And I wrote something here that's very insightful, and then that's something we're going to trace as well. And look at, take a look at what I wrote. I said over here, I said calling A.MA did not cause the exception versus calling A.MA caused the exception. What does that mean? That means this line here, line number 9, potentially may or may not throw the negative value exception. And we're going to somehow simulate the execution flow by different values. For example, if I is past -5 versus I is past +5, the flow will be different. We want to see exactly how the flow is going to go differently when you got different input value. Some input value might trigger the exception. Some input values may leave the flow just to be normal. So these are the 2 things we're going to see, okay, in a moment. All right, any question about B here? We're good? Yes?
I'm just wondering, isn't it a better coding practice to make the try and catch in class A instead of class B? Because for every instance you make of A, you're going to have to do the same try catch.
So in some way, well, it's a good question here. I would say whether or not, where to really put a try and catch option here is complete to your design rationale, how you want to justify it. I'm just saying typically, if you're programming a method where some error might be, an exception might be thrown, that's really like a part of your interface. You want to signal to any potential caller. If you want to use the method here, you better be sure you pass me something that's valid, right? So I would say just a common practice for the very first method where you want to throw the error, you should really let all the caller be aware of the error. That's why. Yeah. But after that, whether you want to have the immediate caller, in this case B, to catch it or to specify is completely up to your choice. Yeah, it's more like a design issue. It's nothing to do with the programming per se. It's more about design. Okay. Good question though. Okay, let's now create one more class, right? This is something I promise I'm going to show to you. This is very important, okay? So what we conclude from class B is as follows. Class B here, we choose the try and catch option, right? So that means the exception object is really caught at this level. It's not going to be propagated any further. That's important, right? So let's now create a caller of MB. And notice that as part of the header of MB, does it say anything like throws negative value exception? No, it doesn't. That means anybody calling MB will not be subject to catch or specify requirements anymore. That's very important. Okay, let's now take a look. All right, so let's now just go to version 1. Let me create a new class right here. So new class. Let me call that tester. And then I can choose to have a main method, right? Just for illustration. Right here, all right? So tester here. And I'm just going to create a local variable. Let's say integer I. If you look at this example on the slide, it kind of shows you how you can use a scanner to take some input from the keyboard, right? Just like a fancier version. You can give it a try. But for now, I'll just put the simpler version. For example, I can say, let's say 5, okay? I can change the value later. And then I'm going to create, let's say, B. Object B will be new B. And then I will try to call OB dot MB. And then pass the value of I. And system.out.println. And I will say, let's see. I would say we are now from tester.main after calling n.b.mb. All right. Number one thing for you to notice, line number 8, we're calling MB. Is there any compilation error at the moment? No. Everything compiles. It's simply because at MB, we already caught the exception. So exception can no longer be propagated to this level anymore. All right? That's very important. Okay? So you can say that tester.main is no longer subject to the catch or specify requirements. Okay? Let's take a very quick look, and then we'll do some tracing. Okay? And we can answer some questions as well. So this is the call stack we are talking about, right? So we got tester.main over here. That one calls b.mb, and b.mb calls a.ma, right? That's the call chain that we have. And then we have this a.ma. That is where the exception is originated, and then it will simply try to specify the exception, right? So that's what we got throws as part of the header. So this one here is about the specify. And then if you check back to b.mb, you can see for b.mb, we actually got a try and catch option. So that means we keep the exception to b itself. It doesn't really get propagated any further. All right. So this part over here is really the catch option. Okay. So that means the catch with specified requirements only applies up to this point. Beyond this point, catch or specified requirements no longer enforced. So this is why in tester.main, when you actually call b.mb, you don't really have to either specify or catch. It's a very important insight. So in version number 2, I'll show to you, you might be wondering, how can we also let tester.main also be subject to catch with specify? How can we do that? Basically, you want to let this arrow, rather than keeping to b.mb itself, you want it to be propagated to here. In that case, b.mb will actually specify rather than catch. That's in version B, we'll see. All right. All right, let's answer 2 questions here very quickly, and then we'll do some very quick tracing. Okay. So in b.mb, is it subject to catch with specify? Yes, indeed, right? So b.mb. So we are really talking about this particular line over here, right? In b.mb, yes. Because a.ma specifies the exception. You can see over here the callee ma actually throws that particular exception. So it's being propagated. So in b.mb, the caller, it is subject to it. On the other hand, what about in tester.main, right here, right? Tester.main. So here we're calling mb method here. But here you can see we are neither throws, we are not really throwing any exception for the main method, and also we are not trying and catch anything, right? So that means it's not subject to it anymore. Okay, so no. No, because b.mb catches the exception already. All right. And I want to do some tracing together with you, okay? Just to see how the exception may be thrown or may not be thrown. It's not always being thrown, okay? depending on the value. So let's now do some exercise on the paper first, and then we try to do that on the Eclipse just to double check. Okay, so at least you will know how to do it. Let's remind ourselves about the stack, right? Very quickly. So the entry point of execution is going to be the main method. Okay, so the tester.main, which calls b.mb, which calls a.ma, right? I'm going to talk about two values over here. Okay, so for now, let me just get it completely clean right here. Okay, let's try two values here. You can see we got integer I here, right? So this will be an entry point of execution. We can assign different values to it. Okay, so let's say case number 1. Let's say we assign 5, which is positive to it. And then we're going to use label 1, 2, 3, 4, 5 to really see how the flow of execution is going to go. All right. So we start from 1 here. And then number 2, we create the B objects. For that one, we don't need to visualize. It's not the point, right? We know how to, we just need, for this example here, we just have to know how to step into the method. And then we go number 3 here. And remember the exercise we did earlier. So now we don't really go on to the next, because now the execution for tested domain will be suspended. We got to go into MB, right? MB is right here. So this will be the first line, okay? So number 4. All right? And then we go into the try block right here, right? So you can choose to really say this is number 5, or you can simply say this is number 5. Doesn't really matter. It depends, right? Why don't we say we go into the try block? So the first line for the try block should be number 5. Okay, number 5 right here. Again, we don't really go on until we actually execute MA, right? So let's go to MA. MA is right here, right? At this point, the value for I is really 5, right? So we're going to go to MA. So I value is 5. And then we're going to evaluate I less than 0. 5 less than 0 is false, right? So we're going to go to, so you can think about this part here is bypassed. So we don't throw the error. And then we simply go to the else part. So this will be 7. So what we get is we say something like normal execution of a.ma. All right, good. So you can think about at this point here, A is done. So we go back to B. And we go back to B. Now, where should we go? Tell me the line. Where should be number 8? Not exactly. Oh, you can miss that, right? Yeah. So remember, right at the top of the stack is MB, right? So that means we should really resume its execution. Yes. Okay, good. Just watch out. It's a good try, okay? It should be right after 5. Yeah, that's correct. Yeah, good. Okay, awesome. So this will be number 8. Okay, we go there, and then we'll print out from b.mb, and then we say calling a.ma did not. So guys, this line here is very important, right? So what we are saying is you call some line right here, ma, which may or may not throw some exception. For certain input value, the exception may not be triggered. That means you will be able to continue from here and then go to the next line. We'll see another input value where we cannot do the same thing. Okay, just remember that inside, okay? So now after number 8, right? So now we're basically done with the whole try block. So here's the rule. Once the try block is done, and you haven't really branched out to any catch block, that means no exception has been thrown. In that case, you bypass all the catch block as well, all right? So now you're done with the very last line for the try block, so the remaining part, the catch block will be done. So here I didn't put any additional line. Let's say if there's any additional line outside the catch block, it might still execute it. That's something you can give a try. Okay, so after number 8, we are basically done with MB, right? So done with this. So now, what should be line number 9? I'll let you tell. From test to the main. Yes, exactly. Okay, that'll be number 9, right here. So it's going to be from tester dot main, and etc. All right, we got 9 steps in total. When the input value being 5 will not somehow trigger the negative value exception from a.ma. Any question? All right, so let's now try another input along the side. Okay, let's try -4, for example. And I'm going to use the same page but a different color. Okay, so let's say if you change the value here from just to -4. Okay, we're going to run over everything to see how the difference is going to be. Okay, so 1 will still be the local variable declaration and initialization, and number 2 will still be creating object B, and number 3 will still be that we actually try to call the method, right? Okay, so the stack is going to be more or less the same. It's going to be the same stack, really. Okay, so let me just reuse the stack. Okay. So here we got this, right? Number 3. So now we're going to be we're going to suspend test.ma, and then we're going to execute b.mb. So put that on the stack, right? So number 4 will still be we try to execute the first line for mb. That will be the same. So far, so good. And then the I value here we are trying will be -4, right here. So when we go to 5 over here, okay, -4, right? We're still going to step into the execution for MA. So we go to MA over here, and the value we're going to try will be -4. Okay, and we're going to evaluate the condition. So 6 will still be the same. So far, from 1 to 6, the same. Now, here's the difference, right? So -4 less than 0 will be true. That means, first of all, we're going to go for 7 here. We're going to print it out. So we're going to say abnormal execution of a.ma. So this is going to be printed out first. And then we're actually going to throw that exception. You can think about this is where the exception is originated, it's being thrown. And since we say throws, it's a specified option. You'll be propagated to b.mb. So that's okay? Okay. So now the question is, so this is propagated back to b.mb. So if you look at b.mb, this is where we actually call the MA. But now MA has triggered some negative value exception. That means we don't really go to the next line because now the execution is abnormal. So where do we go? We should go to the catch block that will catch that particular exception. In this case, the only catch block we have is the negative value exception. So this one is going to catch. So negative value exception will be caught right here. All right. So we got number 8 should be exactly the first line right here. Number 8. All right. So after that, we're going to say from b.mb. b.mb. And then we say calling a.ma caused that exception. Okay, you can see the critical difference is really here, right? Either did not or it actually caused. Right? So these are the 2 points. All right, so after number 8, so we are done with the catch block, right? So the whole thing's done. So we are now done with MB. So basically these 2 are removed from the stack because they finished their execution. So now where should be 9? Right? That's a question. Yeah, go ahead.
It would be same place.
The same place, actually, because somehow MB over here is done, right? Because that one already triggered this print out. So it's done. So now we go back to 9. Would be just the same place. 9. Okay, so that will be from tester dot main right here. Right? So these are the two different flows you might have. Let me just highlight one more thing and then answer your question. Okay? So if you compare the trace over here and the trace over here, of course, one is about the exception was not cost, and this one about exception was cost. And also you can see one thing there is about normal execution, and the other one there is about abnormal execution. Okay? These two. Yeah, question?
Wouldn't the stack unravel as soon as an exception is thrown? So the process would terminate, it wouldn't go to the print line contesting.
You mean this one here, right?
Right, yeah.
Yeah, so you can think about, yeah, so a.ma was somehow added to the stack because we're executing this method here. As soon as we say throw new exception here, we know that the method is basically done, but terminated abnormally. So that's why it will still be removed, but now we should really try to handle the exception from the next caller, which will be b.mb. So that's why we go to where we are supposed to resume.
I guess my question is then, the print line statement in tester dot in class tester, it wouldn't execute, once the exception is caught, wouldn't it terminate the process entirely?
You mean this line here?
Yeah, after the exception is caught, so in
Oh, you mean this one here, right?
B, yeah.
Okay, yes.
Wouldn't the process terminate at that point after printing that one?
Okay, so let's say we are following the red one. Let's say we got -4.
Yes.
Okay, so after the exception is thrown, that means this method is done.
Yes.
Okay, so we go to b.mb. So we resume from this particular line. Okay, so this line here goes like this. Because the exception that's being thrown is being propagated, it's not being caught in a.ma. Right. So that means from this point here, the exception is somehow thrown from here. So that means you cannot just go go to the print line right away. Right. So once it is thrown, you're gonna at the runtime, it's going to look for the relevant catch block to catch it.
Yes.
Right.
I mean the print line in class tester, that print line statement at the end, would that not be?
It will still be printed because, so are you okay with, let's say, this from this line here, the negative value exception was thrown. So that means we'll go to the relevant catch block and then we'll print this line. You okay with it?
Okay.
Good. So after this, b.mb is done.
Yes.
So we go to tester.main. And tester.main was actually right here. This is where we actually got suspended. So we're still going to continue with it, right? So we still continue from there, right?
So even if an exception is thrown, the process doesn't terminate. Right?
But except as far as we are concerned, the exception was already somehow caught from this level over here. So after this point here, you don't need to worry about the exception anymore. Okay. Yeah. So we can see maybe another version. You will see even more about how the execution flow is going to go. Right? Right, so try to really go over this flow here. So there are many subtle points you want to watch out for, okay, for this one here. Okay, I will show you just one case about how you can use a breakpoint debugger. But I think for in-class lecture, we try to focus more on the paper, just so you can see more conceptually how things go. I'll just show you one case, okay? Let's say, for example, let's say we want to test for -4, okay? How would you do that, right? Okay, I'll just do one, okay? So let's say we want to change the value to -4 right here, okay? Right here, like that, okay? And then I'll put a breakpoint in line number 6 right here, okay? And then I'm gonna run the debugger and then go line by line. I'll show you maybe different passes for the same input, okay? So first of all, let me launch the debugger. And then we should really pause at line number 6. Okay, just take some time. Okay, switch. Okay, we're now in line number 6, right? So let me also get the variables panel ready. Okay, let me just drag this a little bit to the left. Okay, so you can see there's a variables panel. Okay, let me just go a little bit like that. Okay, at the moment, I has not been declared just yet. So let me say step over. Okay, if I say step over right here, so now I do have the I value. Okay, just somehow it's not really exactly shown over here. But maybe try in your debugger. Somehow it's not shown properly in the projector. But if you actually move your mouse over the I, you can see that the value is -4, right? That's another way to see it, right? You should be able to see that. All right, so now we create object B and step over. Okay, we're calling this, right? First of all, I don't step into just yet. Now here's a question for you. If I say step over, right? That means it's going to execute OB.MB. We know that at some point behind the scene, it's going to trigger the negative value exception from A.MA. And A.MA is going to throw that exception, and B.MB is going to catch that, right? So now, as far as this line is concerned, are we going to see any exception here? The answer is no, okay? So if I actually say step over, right? So these two lines are exactly what we said earlier, what will be printed, right? And then if you step over again, you're actually going to have the third line, right? So that's how we have. So from the tested and main point of view, you don't see any exception there. You don't see that, okay? Let's see another pass, okay? That's the first pass. And for the second pass, I'm going to step into, okay? Okay, let me launch the debugger again. Okay, so now second pass. Step in, step over, right? So now I know the I value is now -4. So I'll step into. Now I'm in MB, right? The try and catch block, all right? Important question for you, okay? At this point, I'm now in line number 9, right before executing it. And the I value, I can also move my mouse over, it's -4, all right? Question for you, if I say step over, where would it go? Tell me some line. I'll give you option, how about that? So guys, it's an important question here, let me ask one more time, okay? I know that at line number 9, I'm calling MA with the value -4. And if I say step over again, not step into, only step over, am I go to 10 or 12, 13 block? The catch block? Agree?
Yeah.
Okay, awesome, okay? Very good. But it's the second pass. For the third pass, we're going to step into again. But for now, let's keep this level. If I say, okay, watch out, you're going to really see the line number 10 is going to be skipped, all right? Step over, you can see we go directly to line number 13, all right? Just in the Eclipse debugger, they don't really stop at line number 12. It doesn't do. You know, you would just go to the relevant catch block that's going to catch the exception. So you go directly to line number 13. Also correspond to what we said earlier. If you say step over, you go to the end of MB. And then, of course, you will go back to tested and main. If you say step over again, you go to the final line in tested and main, right? So you want to really see this exercise here with how we did it on the paper, okay? So if I say step over once more, we got all the 3 lines as before, okay? That's the second pass. Let's do one more pass, okay, just to be complete. Let me launch the debugger one more time. Okay, we're now here. And then step over, okay? Now we're calling MB with a -4, step into. And then we are now in the class B.MB. And then step over, right? So now the I value is actually -4, okay? So let me now step into it once more, okay? One more level. If I say step into, right here, I'm now in A.MA, right? And the I value here is -4, right? And -4 is less than 0. So if I say step over, which line would I go? 8 or 11? 8, agree, right? Okay. If I say step over, exactly, okay? So, and then this is right before I throw the exception. Okay, so now let's predict what's going to happen. As soon as I say step over from line number 9, the exception is going to be thrown. What does that mean? That means from the paper over here, once the exception is thrown from A.MA, because that method specifies it, it's going to be propagated to B.MB. So we're going to resume the execution from B.MB. And B.MB used to be right here calling MA. So now if the exception is thrown, rather than going to the next line, we're just going to the catch block that will catch the exception. That's what we're going to see. Okay, let's just see that, and then we are done with this particular demo. All right, let's now try to step over again. Right, you can see now it shows that in MB we didn't really go to this line, right? Remember? So because this line here already triggered that exception, so we bypass line number 10. We didn't go there, and we just go to the catch block that will catch the exception. And step over again, he's going to print out this line, and everything else will follow. Okay. All right, guys, any questions so far? Version 1 will maybe take us the longest because I really want to make sure I show you both the paper and also Eclipse. I think for Eclipse, that's the only thing I will do. It's quite time-consuming, practice that. And for the paper, I can still do version 2 and version 3 quickly with you. Okay? But I got to be very clear about whenever you're executing a line that may or may not throw an exception, you got to decide for that particular input value, is it going to trigger the exception or not? Right? Go ahead, please.
I had a question about catch.
Yeah.
For the negative values, do we have to throw like NVE exceptions or just exception will do as well?
So good question. If I understood correctly, you're basically asking right here for this part here, can we, rather than saying negative value exception, just say exception?
No, like for the NVE part.
NVE part?
Yeah.
Okay, think about it's more like a declaring a parameter, right? So this is just the name of the parameter. I just use the first letter, NVE. Or you can simply say E, that'll be okay. Or you can even say X, as long as they don't have any name clashes. Doesn't really matter. Because once you name some variable here, you can use it inside the catch block, right? Like a method, a little bit like that. Good. All right, guys, any questions? Okay. Why don't we take a very short break, and then we'll do version 2 and version 3 very quickly, and then we can generalize the scenario, okay? All right, so before the break, we spoke about version number 1 on paper and the Eclipse. So now let's go over version 2 and 3 as well. So for version 2 and 3, I'll try to present at a slightly higher level, so you just kind of see what the differences are. I think that's more important. But you really want to do the exercises of tracing on both the paper and also on the Eclipse. They're rather important. Okay, let's look at version 2. Okay, for version 2, we still got 3 classes. Okay. We still got A, B, and tester. A stay the same. This is where the exception will be originated. And we got class B here. So now class B, if you remember in version 1, class B, beta and B will specify the, will actually catch the exception, right? If you remember. Let me just show you. Right? You can see beta and B catches the exception. Let's say you choose a different option. You will simply choose to specify the exception. Right? In that way, we're simply just much simpler to write. We say BMB here throws that particular exception just like the origin of the exception, like a throw. So now we got 2 places which we'll specify. So if you look at the call stack right here, right, you can see that we try to specify from the original place. Also, we try to specify again. Right? We got 2 specifies. That means this tester domain will be subject to the catch with specified requirements. In the previous case, it wouldn't be, right? So in previous case, we drew a line, right? You want to compare. That's the first thing to really compare. Why? The tester domain in version 1 will not be subject to the requirements. But in version number 2, it will be subject to because it still get propagated the exception. Okay? So we're going to modify the code and see how things will change accordingly. Okay? Let's see. And of course, once you get to test the domain, since it will be subject to the catch with specified requirements, you have to choose, do you want to catch it or specify it? Right? We're going to see catch version first. All right? So what I will do is, let me just go to Eclipse. I just want to show you exactly the difference, right? So let me just copy version 1. Okay? So copy, and then I want to paste. And I'll call that version 2. Okay, version 2. Okay, in version 2 here, we still got A here. Doesn't change, right? Let me close everything so we don't get confused. So class A stay the same. But for class B here, we're going to change it. You can see we are now under version 2, right? So now we are not going to use the try and catch. We simply want to propagate the exception further to test the domain. So we simply get rid of the try block and also catch block. We simply don't need the catch block at all. Okay, fix it like that. And of course, as soon as I do this, right, I got the compilation error because I'm not really satisfying the catch with specified requirements. If you move your mouse over, you can see this one here will say unhandle exception, negative value exception, right? So let's say we choose to specify it, right? I'm going to say right here, throws negative value exception. That will fix the error. However, we still got error in the whole projects. Do you know where? B is okay. You cannot see it here because now if I go back here, let's see version 2 project, right? You can see the project itself got cross. Something wrong. A is okay. No red cross. B is also fine. But tester is not okay. That's a very important highlight for you to see. All right? If I double click on tester, right here, if you recall what we did in version 1, in version number 1, because B.MB catches the exception, so we don't have to do anything in test domain. But now in version number 2, the B.MB only specifies the exception. So the exception is being propagated to test domain. So the test domain must do something about it. At the moment, it's not doing anything, right? So if you move your mouse over this method called unhandle exception, negative value exception, right? How many choices do we have right now? 2. Catch will specify, right? Why don't we just try catch option quickly? Apparently, you can say catch will specify. So you can say try, and then I'll try this one here. And catch. Okay, I'll just put this line here right after executing it, right? And then negative value exception. Okay? Over here, there will be something here. You can put a line. Okay, I'll let you do whatever you need to do over there. All right? So this will fix it because now in the test domain, we actually chose the catch option. All right? So now everything compiled. But what we want to see is for version number 2, how is the code going to handle the exception exactly? That's something we would like to see. Okay? So let's now answer 2 questions there, and then I will do just one tracing quickly on the paper. But I would suggest you also reproduce the tracing on the Eclipse as well. That's also important. Okay? Question 1. In version 2, B.MB is subject to catch with specified requirements. Indeed, right? Because this line here, definitely, it is subject to it. Yes. And B.MB specifies negative value exception right here. And because that one there actually propagates the exception to test domain. So how about test domain? It is also subject to the exception as well, right? So you can see over there is calling B.MB, right? From tester domain. Yes. Tester domain specifies it. Okay, like that. Let's now try to trace just one case, just to see what's going to happen. What about we try the abnormal case when the exception occurs? So let's say here, integer, let's try maybe -3, doesn't matter, it's just a negative value, okay? So number 1 and number 2, create the objects. Number 3, and we're gonna step into the method call. So we go to MB, the value is going to be -3, right? -3. So number 4, about creating object A, and number 5 of calling MA with -3. So far, so good. And then we are actually going to execute MA here, and the value is -3. Okay? So we're going to evaluate that line, number 6. minus 3 less than 0 should be true. So we go to 7 here, right? We're going to print this out, okay? And then we're going to throw that exception. Because this exception is going to be thrown, so we don't execute anything else. You can think about the rest of the method was simply bypassed. So where should number 9 be? Anybody? I'll give you a little bit of hints. As soon as, think about the call stack. How about that? That'll be a little bit easier. This is important, right? A little bit tricky. Oh, sorry. Let's recall the call stack. We got tester.main, and also we got b.mb, and also we got a.ma, right? At this point here, the negative value exception is thrown. So you'll be propagated to right here, right? Of course, as soon as it's has thrown the exception, this is gone. So we should somehow resume the execution for b.mb, right? Now, where should I put number 9? Go ahead. Print line from where? From which class, which method? You mean this one here? Okay, any other answer?
It would be in the catch block in tester.
Aha, okay. Okay, good try, okay? So now, let's understand why it will not be this line, okay? Thinking this way conceptually, if I'm calling a line here, and if this line ever throws some exception, either from itself or maybe from the method it's called, in this case, a.ma is going to throw you the exception. As soon as the exception is thrown, you're not going to go for like a normal execution to the next line. You will only go to the next line if nothing happened. All right? So this is not right, okay? So that means this one here, because this part here simply propagate the exception. So we simply propagate the exception to the next one. So now we're going to resume the execution for the main method, which is right here. So now if you resume it, it's going to resume from where we were, right here. Okay, now another choice, right? Should we actually go to this line here, or should we go to this line? It should be the latter, because the negative value exception is being propagated to here. So there's no way we're going to go proceed normally like here, right? So we still bypass that one there. So we're going to go to the catch block. So that means number 9 is going to be here. Only this one will be printed out. All right, so let's recap about this one here. Let's do the highlight. So we start with here by setting the input value, and then we create the objects, and then we call this method here. And then we create A and call that method. And we step into this method MA here. So we check the value. That's the error condition, satisfied. So we're going to print out the line here, and then throw that exception. So once this exception is thrown, we're going to resume the execution from here, and we don't really go any further. Going further means you're going to proceed normally, but it's not normal because the exception has been thrown. And then we're going to go to here, which will be the top of the stack right now. So MB over here is going to throw the exception as well. It's going to propagate to here. But so we don't proceed any further. So we just go to this one here. Okay, version 2. All right, question? Yes? Very good question. I'm pretty sure somebody will ask. I'm glad it's you. Okay, we're going to see in version 3. Okay, so guys, are we okay with this version here? Good, right? Version 3. What if nobody wants to handle the exception? Nobody wants to catch that. It should be a no-no situation in your case, of course, right? But let's see what's going to happen. I'm curious too. All right, let's see. So let's now create version 3. Version 3 is going to look something like this. So A stays the same. Oh, sorry. A stays the same. It simply specifies it. B also stays the same. Also specifies it. Tester.main also specifies it because you can see throws. So as far as the compilation is concerned, we are fine. Because every caller, in this case along the stack, they try to handle the exception by specifying it. But the outcome is not very pleasant. Let's see. Okay? So let's now create version 3 from Eclipse. So what I will do is, let's now try to create version 3. So copy and paste. So version 3, all right? So version 3, the only place I'm going to change will be the tester. Okay, let me just close everything else. Okay, let's go to tester, all right? Right here. So now for tester.main, the entry point of execution, I don't even want to catch it, right? I just want to specify it. So get rid of this block here, and I don't need to try and catch. Of course, if I only do this, I'm going to get a compilation error because I have neither specified nor catch the exception so far. So that's why I got that error there saying unhandled exception. But let's now handle that by specifying it. So I can say right here, throws negative value exception. Everything compiles. Okay? Let's see what's going to happen here. Let's see on the Eclipse, not debugger. I'll just show you what's going to happen. We got -4, which we know is going to trigger the exception from a.ma at some point. However, no caller along the way is going to catch it, including tester.main. So if we simply execute just this one here, okay, right-click on that, run as Java application. All right, that's what we got. You can see that negative value exception is thrown directly to the console. You can think about you are the client or user of this AB and tester. Somehow you are thrown this particular exception to the console. That's very bad because you are not supposed to have any knowledge about it, right? It's a no-no situation, right? You want to make sure along the call stack, there should be at least one class or method that's going to catch that exception. Okay, I'm going to generalize this scenario to you in a moment. Okay. All right, very quick. Okay. So guys, let's answer these two questions very quickly, right? These two, and then I'll give you some exercise to try at least. Okay, 1. Okay, that's version 3. So beta.mb, of course, it is subject to catch with specify. Yes. B.mb specifies it. Specified negative value exception. And also for tester.main, also specifies it, right? Doesn't catch it. Yes. So tester.main specifies the negative value exception. Okay, exercise for you, all right? You want to see exactly how that exception got thrown. What if I set I to be, let's say, -10? Well, really the same thing. Okay, and trace it. What you really want to do, I'll help you one more thing. You will gradually build a call stack from here. You're going to, entry point of execution is going to be tester.main, put it here, and then b.mb, put it here, and then a.ma, put it here. And try to apply how we trace the chain of method call from the other day. Right? I think this will be a valuable exercise for you. Okay? And I'm pretty sure you're ready to do it. You just need to follow what we just taught so far in the lecture. Any questions? Okay, please do the exercise and then reach out to me if you got any questions, right? For your exceptions, you will definitely get a chance to practice that from lab number 2. So I think we cover enough for you to really at least get started, okay? Let me now kind of summarize about what we have seen so far. Okay, let me start with this one here. Okay. Let me start with the big picture. Let me start with this one here. Okay, don't be too terrified by the symbols, but that's really the most precise way to see what's going on. Okay, I'm trying to basically make, for our version 1, 2, and 3, we're talking about only 3 methods there. We got a.ma, we got b.mb, we got tester.main, only 3 methods. But in general, in a realistic project, you may have maybe 10 methods in the method call. You may have 100 in the method call chain. It's completely reasonable, right? So why don't we just make it completely general? Okay. Let's say we have a call stack right here, like that, okay? And then let's say in a call stack, we have from method 1 all the way to method n. So we got n methods, first of all right? I'll go bits by bits together with you just to understand that. So we have a call chain, okay, right here. So we have a call chain. of n methods. Because you will see that n, because you got from 1 all the way to n. And then just for make it general, so the class, maybe just different classes, C1, C2, all the way to Cn. Sometimes class may duplicate, that's okay, right? Just different methods, okay? And of course, the bottom there is the entry point of execution, this one here. So this is the entry point of execution. So we start from there. That could be tested at main, for example, right? And the top one, presumably, will be where the exception will be originated. So that's why we stop growing to call stack, right? So think about right here, the top. Over here. So this is the origin of the exception. Okay, so origin will be C1.M1. All right, we'll see how things will go, right? And there's only one assumption I have to make, right? Oh, actually, let's do also one more thing that you also know. We know that since this is the origin of the exception, we know that this method here is going to specify it. This will specifies the exception. So that one is really like a rule number 0 that we talk about for catch with specified requirements. Okay? And let's make the following assumption. Let's say this particular method, method I, is the very first method that is going to catch the exception. Okay, I'll write it down, and then we think about what the consequence is. And this will be the point to really clarify the understanding, to make it general. So the method here is assume. So this is a very important assumption. Assumption Ci.mi is the first caller that catches the exception. And we know that exception is from C1.M1. Right? Just make the context very clear to you. Okay? That's a very important assumption. Okay? It's the first caller that catches the exception. What that means is all these will specify the exception. This one here will specify it, this one will specify it, this one will specify all the way to this point. And this is the very first method that will choose to catch it. All right? All right. Let's see what the consequence is. So accordingly, oh, actually, you know what? Let's answer this question here. Given this assumption here and then set up, can you tell me precisely the methods that are subject to the catch word specified requirements? First of all, tell me how many methods are there that are subject to the catch word specified requirements, which means they have to either catch or specify, right? Literally, right? How many are there?
There's I methods.
I methods, okay. Anyone else? I as well, okay, I agree. Okay, which I? Which I methods?
MI.
MI is definitely one method. What about, how about MI plus 1?
It's already been taught.
So tell me exactly, you say I methods. Which I methods? From what to what?
From 1 to I.
1 to I, okay. I agree. But we want to be even more precise, right? Okay, I agree. The answer is right. First of all, I methods. So that means this part here are the methods that are subject to the catch with specified requirements. Out of all these I methods, have they committed to the same option to satisfy the requirements? If yes, or if no, you gotta explain to me. Let me ask again. Out of all these I methods from M1 to MI, have they committed to the same option to satisfy the catch with specified requirements? For example, M1 specifies. M2, does it specify or catch? Specify? How many specify really? How many? They all specify because you're definitely on the right track, okay? So basically, since we assume this is the very first method that will catch it, that means all the previous one should have not caught it just yet. You can only have one catch, and that's the terminating point of the catch with specified requirements. So that means, good, so I'm going to write it here. So that means what we have is like this. From everything here, all the methods before MI. Okay, just right here. That means C1 dot M1 all the way to CI minus 1 dot NI minus 1. Specify. And this is the only one that catch it. Okay. So now I methods, right? So now to be more precise, I minus 1 methods specify. And one method catches. Okay? So all these I minus 1 methods, all these I minus 1 methods specify. And the very last one, which you will assume to catch it, will be the only one that will catch it. Okay, next question. How many methods are there, in this case, will be free from the catch with specified requirements? How many?
I think like in the previous thing you said that none of them catch, so everything till I minus 1 will be free from catch.
So, okay, everything until I minus 1 will be the one who actually specified the exception. Yeah. But I itself is also subject to the requirements, right? But it chooses to catch. So now the follow-up question would be, from that point, how many methods will be free from that particular requirements? Yeah. Yeah, I plus 1 all the way to n. Agree? Okay, good. Yeah, it's easy as that, right? So let's now highlight it. Okay, so that one there would be like this. Okay, so all these methods over here, we got n minus I methods. So ci plus 1 dot n I plus 1 all the way to the last one, cn dot n n. So you got m minus I. All right, so you got n minus I methods. All right. Right, so that's completely general, right? Just for you to see about if you got a very long chain of method call, if presumably there should be at one point where you try to catch the exception. From that point, you don't really get subject to the catch with specified requirements anymore. Right, the next two questions is about extreme case, which I can mention to you, right? So for example, let's say exception handle the earliest. So for our rule, the earliest one could be just right here. So maybe C2.M2 catches it. Okay, so I'm really talking about maybe C2.M2. In that case, maybe this will be the earliest point we can try to catch. That's basically version 2. that we spoke about, right? You can do that, okay? And how about version 3? Like nobody wants to catch that, right? That means no method catches. Or you can think about all methods specify, including the entry point of execution. All methods specify. Meaning that exception will be propagated all the way to the console, right? Like what we saw in version 3. Right? That's really the most general picture you can think about. All right? Good. All right, any questions? We good? Okay. So I think I still got more examples here. Let's go over maybe 1 or 2. And then I think I got another like a summary about execution flow. We can do that as a recap on Wednesday. Okay, let's do one or two more example quickly. Okay, so I just want to talk about just more example about exception handling. Okay, so over here we got circle. Okay, and this one here. So let's say this: we have a circle class, and also we have set radius. And the set radius method specifies some exception. Let's say invalid radius exception. If the radius is being passed is less than 0, in that case we cannot really calculate, right? For example, parameter or maybe the area. So we say throw new, and then otherwise we can assign the radius, right? Okay, and then we can also get an area. Okay, let's say we have a class right here. We got circle calculator. Okay. In the circle calculator, we create some circle objects, and then we try to call the method here. And the set radius may or may not throw that exception, right? So now you can see in the main method here, we choose to catch. We don't choose to specify. That's already an entry point of execution, right? So we choose to catch it. And then we can calculate the area, etc., right? And then once you catch the exception, so this is, you can see here I declare the name of the exception here. I didn't call that maybe IRE. I can call that too, right? You can just choose the name. I can say I can choose to print out the exception. You can also do that if you want to. Just get more information about the exception objects. All right. I just want to trace the code together with you very quickly. Okay, let's see what's going to happen. So the caller-callee relationship we have here is very simple, right? So inside this method here, so we got, let's see here, circle calculator 1, and then we got main. Okay, so we got caller will be circle calculator 1 dot main, and then that'll be the entry point of execution, and then we're gonna call set radius, which will come from circle, right? So we got circle dot set radius, right? He's going to call this method, right? Only 2 methods in the chain, right here. Okay. Let's now do very quickly about how the trace is going to go. Okay. And then we'll talk about another one. Okay. You know what? Let me trace this one here, maybe together with you, maybe on Wednesday. I do want to say something here. You can also take a look before Wednesday. I think that'll be worth our time a little bit better. So I have some extended version about the circle calculator. And this one here is going to use a while loop to really handle the exception. This is going to be some interesting example. But I do want you to look at something here. Okay. So here. So we got circle calculator 2 right here. Right. It's a different example. Okay. Circle calculator 2 and main method. I want you to focus on, before Wednesday, look at how this Boolean variable here, I call that input radius is valid. So you can think about this program here is going to keep prompting the user to enter the radius. If they enter something that's invalid, they will be continually be prompted again. So if I enter -4, I'll be prompted again. If I enter -5, I will be prompted again. If I enter 5, and then 5 will be used, right? So that's going to be some logic going on here. Now when you look at this Boolean variable here, initialized to be false. And then I have some while loop right here. And I say while it is not the case that it is valid. As long as the input from the user is not valid, I'm going to keep prompting the user to enter the radius, basically. Right? And then I will try to set the radius right here. Okay, quick reminder, or I can ask you. Let's say this line here, it may or may not throw some exception, let's say. If I'm able to go from here to here, is it normal or abnormal execution? If I'm able to go after this line and go directly to here without going to the catch. That sounds like a normal execution, right? Okay, so if we're able to go to the normal execution, we're going to change the flag to be true, for example. And then, but if we go to the catch block, that means the exception has been caught. In that way, we say try again. So this one here will require some tracing for us to do. So I will pause over here. And then for Wednesday, before that, please take a look at this Boolean variable here, and then we'll trace it together. We just got a few more examples to talk about for exception. Then we should be able to finish the exception lecture on Wednesday. All right? Thank you. See you on Wednesday.